Hello everyone. Uh, this is the third problem solving session for the course Environmental Chemistry and Microbiology. So, in the past two sessions, we have read about buffers, pH, equilibrium. So, in this session today, we'll talk about the reaction rates and reaction kinetics, different orders of reaction. Okay. So I have prepared certain questions. The format of the session is same. So I have prepared certain questions which are similar to your assignment questions, and I'll be asking questions one by one. And I request all of you to write your answers in the chat box, or you can unmute and answer if you prefer that way. And then we'll have the discussion if the answer that you guys are giving is correct or not, and I'll give an explanation for every question uh, as to why and what would be the correct answer. Okay, so feel free to ask any doubt at any point if you have any kind of doubt in any of the topics of this session. Please ask. I'll try to answer as I'll try to clarify your doubt as much as possible. Uh, so I'll start with the questions now. So before starting with the questions, I just want to brush up with one major concept that is being used in all these questions that we are going to discuss. So I told you the session is about reaction rates and chemical kinetics, right? So there are if we have a reaction, an arbitrary reaction, that is A, which is the reactant, and P, which is the product. So the reactant is forming the product after certain time. So in any case, the rate of a reaction is defined either as the amount of reactant that is being consumed or amount of product that is being formed in a particular time frame. Okay, so let's say I want to find the rate of the reaction of rate of this reaction, A goes to P. So either I can say the change in concentration of A over time, over a small time, let's say the time t. So what is the change in the concentration of A in time t? So you know that reactant is forming the product, so the change in concentration is going to be a decrease, right? The concentration of A is going to decrease in order to uh, form P. So that's why the rate is given here as a negative of dA. So D defines as the differential. So if you want to show a very small change, we generally show it in the form of a differential equation, whereas in a very small time t, the change in the concentration of A is given as dA by dt, where A is kept in the square bracket to represent the concentration of A. And we have put the negative sign because the concentration of A is going to decrease. So the so change in concentration means final concentration minus initial concentration. So if the concentration of A is decreasing, then final concentration would be less than the initial concentration. That will make the difference negative. So to make the, and rate cannot be in negative, so to make it in positive, we have the negative sign in front. In case we want to write this same rate in terms of concentration of P, we can also write it as rate is equal to dP by dt. Okay, so this is also one way to represent. So in this case, we'll have the positive sign because change in concentration of P is going to be an increase. So the final concentration of P is obviously going to be higher than the initial concentration of P. Okay, so this is how we define rate. And there's another term called order of the reaction. So how do we define order? So rate is always defined as the change in concentration of A with respect to time t, where, and rate is also written as so here rate is also written as k multiplied by the reactant concentration raised to the power of n, where n is the order of the reaction. Okay, so if there are two reactants, if the reaction instead of A goes to P, if the reaction was A plus B goes to P, then in that case the rate will be defined as K into concentration of A raised to the power of m multiplied by concentration of B raised to the power of n. If there were three reactants, we will keep on adding the reactant concentration and powers. So in such case, in case of two reactants, the order will be m plus n. Okay, so let's take a simplified example where there's only one reactant and one product. In that case, we can define the rate as K A raised to the power of n. So if it's a zero order reaction, that means if the value of n is 0, we can see that something raised to the power of 0 is equal to 1. So the rate is independent of the substrate concentration or the reactant concentration. Rate is equal to the rate constant. K is a rate constant. K is the constant value. K is like the uh, equilibrium constant that we studied in the previous session. Similarly, this is another type of constant value that is fixed for every reaction, and that depends on some physical properties like temperature and etc. Okay, so these are just different ways of representing the rate of reaction for different types of reaction. For a zero order reaction, we have a different equation. For first order reaction, we have a different equation here, and then for the second order reaction, we have a different equation, which we'll see when we are solving the question. We will be using these equations. So I have just added one extra slide to give you an idea that these are the major formulas that we are going to use. But I will request you not to mug up the formula. I would request you to understand how the formula has come into picture. That would be easier for you to understand how to solve any question. Instead of, if you just simply learn the formula without understanding its origin, it would be difficult for you, because even if you miss out one small variable here and there, your answer is going to be very different. So I would request you to understand how this formula is uh, derived, or understand how this formula is coming into picture. Okay, it's not very difficult. So for zero order reaction, this value was 0. For first order reaction, this value will be first. So the rate will be equal to K into A. If you take log on both side and put the limits, you can land up on this equation or this equation, and this is nothing but a straight line equation. So you can understand for second order reaction also. So all the reactions have been written in such a way, like either they have taken the reciprocal, or they have taken the logarithmic, or they have taken the integral, or to make it in a form where we can get a straight line plot, because from straight line plot you can easily find out a lot of different variables. Okay, so y is equal to mx plus c, that is the straight line formula, right? So this is the straight line formula, which is uh, basically in this format they have represented each equation. Okay, so now I'll start with the question. Don't get so confused with these equations. I'll start with the question and you will understand what I'm talking about in the upcoming slides. Okay, so let's start with the first question now. An experiment was conducted to find out the rate of a chemical reaction. The concentration, that is given in kg per liter, was measured at different times. The unit of time is day here, and the data were plotted as follows. So there's a graph given, there's a equation to the graph given. It's a straight line plot, you can see, and you can see the equation of the plot is given. So from this, the order of the reaction and the corresponding rate constant. You have to find the order of the reaction and the corresponding rate constant. So you have four different options. Option A, that order is first order and the rate is 0.541 day inverse. Second option is order is zero order reaction and the rate constant is 0.541 kg per liter per day. Then third option is second order reaction and the rate constant 0.0541 kg per liter per day. And the fourth option is also second order reaction and the rate constant 0.0541 per kg liter per day. Okay. So there are four different options. Write your answers in the chat box and we'll see if your answer is correct or not. All of you write your answers in the chat box. Even if you don't know the correct answer, I would request all of you to attempt the question so that you will understand. Just take your guess or whatever you are understanding based on that answer, and then we'll have a discussion whether your answer is correct or not. Even if your answer is wrong, you will understand why your answer is wrong and what should be the correct answer. So all of you write your answers in the chat box, please. I have one answer in the chat box. That is option D. What about others? There are almost 20 students in this meeting. What about others? I have only one answer. Okay. Okay, three people have answered option D. Let's see the correct answer. The correct answer is option D. So basically, first you have to find what is the order of this reaction. Now, from this graph itself, like the easiest way to see is from this graph itself, it's a straight line plot of 1 by C versus time. So in the previous slide, I have shown you uh, the straight line plots for zero order reaction, the plot is between the concentration versus time. For first order reaction, the plot is between log of concentration versus time. And for second order reaction, it is 1 by concentration versus time. In this, sorry. In this question, you can see the plot is between 1 by concentration versus time. It's a straight line plot. So, from that itself, you can understand that the rate of the reaction is second order reaction. Now, you see there are two options with second order reaction, C and D. Okay. Now, let's see the equation again in the previous slide. In the previous slide, you can see the equation 1 by A, 1 by concentration of A, or let's say 1 by C is equal to KT plus 1 by C0. Okay. So, this is in the form of straight line equation where y is 1 by C. So, we can see the y axis is 1 by C. Here you can see y is 1 by C. This is equal to K into T. So, K is the rate constant, T is the x axis. So, you have 0.0541 into T plus 0.05. So, 0.05 is 1 by C0, that is the initial concentration. So, from this equation itself, you can see what would be the value of K. Value of K would be 0.0541. Okay. Now, you see there are two options where both the options note that the value is given as 0.0541, but the units are different. So, how do we find the unit of the rate constant? Because the unit of the rate constant for every reaction order, it is different. So, the unit of the rate constant for a zero order reaction would be different, for a first order reaction it would be different, and for second order reaction it would be different. So, for second order reaction, what is the rate constant unit? So, for second order reaction, I told you the rate constant is defined as the change in the reactant concentration in a small amount of time. So dCA by dt is equal to Kc raised to the power of 2, because it is a second order reaction. Okay. So now the unit for concentration is given as, what is the unit for concentration given? It is given as kg per liter, right? So we have kg per liter and divided by day, because the unit for time is given as day. So we have kg per liter divided by day. So this is basically equal to dc by dt. Okay. So this is the unit for dc by dt. This is equal to k c to the power 2. So we don't know the unit of k. So I'll just write k into, now I know the unit of c. Unit of c is kg per liter whole square. Okay. So this would be the unit of kc square. So now if I just equate the units both side, you can see kg per liter per day. Day is in the denominator. If it will go up, it would be day inverse. So kg per liter per day is equal to, we don't know the unit of k, multiplied by kg per liter whole square. So now if you just solve this, you will get the unit of k as per kg liter per day. Okay. So if you see in the options, the option D has that same unit. So option D is the correct answer. I can see 5 people had answered option D. That is the correct answer. I hope rest of you who have not answered, you understand why option D is the correct answer. Anybody has any doubt on this? If you have a doubt, please let me know. If you have a doubt, you can write it in the chat box or you can unmute and ask. Meanwhile, I'll move to the next question, question number 2. The radioactive nuclide P32 has a half-life of 14.3 days. What fraction approximately of the initial P32 will remain after 84 days? Radioactive disintegration follows first order kinetics. So it's a first order reaction. The half-life is given as 14.3 days. You have to find the fraction of the initial P32 that will remain after 84 days. Okay. Options are 17%, option B 1.7%, option C 83%, and option D 98.3%. So solve this and let me know the answer. Radioactive nuclide P32 has a half-life of 14.3 days. What fraction of initial P32 will remain after 84 days? Radioactive disintegration follows first order kinetics. So you have to solve it based on the first order reaction equation, rate equation. Okay, I have 2 answers already in the chat box. Option B. Okay. Okay, 4 people. Okay. Okay, most of you are answering option B. Let's see the correct answer. The correct answer is option B, 1.7%. Let's see how to solve this. So, from the rate equation of first order reaction, we know that log of initial concentration divided by the final concentration is equal to K into T, because your reaction rate is first order. So your rate would be, just a second, Yeah. So your rate would be equal to K into C raised to the power of 1, right? And this will also be equal to minus dC by dt. And this will, sorry, I'll just open the slide. So from this slide, you can see the rate is equal to minus dC by dt, and it is also equal to K into C or K into A. So if you solve this, if you take log on both side and if you integrate on both side and take log of it, as you will get log of initial concentration divided final concentration is equal to Kt, right? So that is what we are using here. So it's a first order reaction, first order reaction, a first order kinetics is followed. So we'll use this equation. Now half life is given as 14.3 days. So what do you mean by half life? Half life means that that is the time required for that particular reactant to degrade into half of its concentration. So if the initial concentration was uh, if the initial concentration was 100, this time will be required to reduce that to 50. Okay, so whatever will be the initial concentration and final concentration, the ratio will be 2, because 100 by 50 would be 2, or if it is 50 by 25, then also it would be 2. So half life means C0 by C will be 2. Okay, so log of 2 is equal to K into T half, because at that particular time, that is the T half. So from that you can calculate T. So natural log of 2 is equal to 0.693. So 0.693 divided by T half would be your K. Okay, so once you have your K, again you put the same thing in this equation and you find the C by C0. Okay, so if you take the negative value, it would be ln of C by C0 is equal to minus KT, or you can then take the log on this side of the equation. On the right hand side, it would be in the exponential form, and then you can solve for C by C0. So the ratio will come to 0.017. If you multiply it by 100, you will get the percentage, that is 1.7%. Okay, do you have any doubt in this?
No, ma'am.
Okay, great. If anyone has any doubt, please write it in the chat box. I'll move to the next question now. Okay. Question number 3. Consider the reaction 2A plus B goes to product. The rate of the reaction is 4.8 into 10 raised to the power of minus 4 mg per liter per hour. If concentration of A is equal to concentration of B is equal to 0.4 molar, and rate constant at 300 Kelvin is 3 into 10 raised to the power of minus 3 liter per mg per hour. What is the overall order of the reaction? So you have to calculate the order of the reaction. You have the reaction 2A plus B goes to product. The reaction rate is given. The concentrations of reactants are given, A and B. The concentrations are given, and the rate constant is given. So reaction rate is given, K rate constant K is given, and the concentrations of A and B are given. Okay, you have to find the order of the reaction. Options are 0, first, second, and third. You calculate the order of the reaction and write it in the chat box. Okay, I'm getting one answer here. Okay, a lot of you are answering option C, that is second order reaction. Let's see that is the correct answer or not. So that is the correct answer. The reaction follows second order reaction kinetics. How I'll let's see how to solve this. So I told you rate of any reaction is given as the concentrations of the reactant raised to the power of the orders raised to the power of like variables which will add up to the order of the reaction. So for this reaction we can write the rate as k, that is the rate constant, into a to the power of n multiplied by b to the power of m. So the concentration of a raised to the power of n multiplied by concentration of b raised to the power of m, and the order of the reaction would be n plus m. Okay, so in this case we have the rate given, we have the rate constant given, we have the concentrations of a and b given. All we have to find is the value of n plus m. Okay, all we have to calculate is the value of n plus m. That would be the rate constant, sorry, rate order. So reaction order. So the rate is given as 4.8 into 10 raised power of minus 4. Rate constant is 3 into 10 raised power of minus 3. The concentrations of A and B are given equal, that is 0.4 molar. So 0.4 raised to the power of n multiplied by 0.4 raised to the power of n m. So this we can write it as 0.4 raised to the power of n plus m, right? And if you take 3 into 10 raised power of minus 3 on the other side of the equation, you will get 0.16, that is 0.4 whole square. So the value of n plus m comes to 2, and that is the order of the reaction. So the value of n plus m is 2. That means the reaction follows second order kinetics. Is the solution clear to everybody?
Yes, ma'am, clear.
Great. Okay. So I see most of you have answered option C. People who haven't answered, I hope this is clear to you. If anybody has any doubt, please write it in your chat box so that I can understand what your problem is and then I can help you out with that. Please do not hesitate to ask the questions. This session is only for clearing your doubt. So if you have any sort of doubt, please let me know. Yeah, Samajita, you are raising your hand.
Yes, ma'am. Ma'am, in this question, as it is said that, like we have, like in the previous question, you said that the radioactive disintegration is the first order kinetics. Like, is it applicable for any sort of radioactive disintegration?
No, no, no. That depends on the, mostly radioactive disintegration follows first order kinetics. That's a different principle. But then those questions are like, in those questions you will be given, if it follows some other order, it will be given in the question, like it is, if it is a second order reaction, a third order reaction, something like that. Okay. So
And
mostly,
ma'am,
like when
how
you
it
will
is?
when we will study about radioactivity, you will see that it follows first order reaction kinetics, but that is a different part of the question altogether.
Okay, ma'am.
Hmm. Anything else?
No, ma'am.
Okay. Okay. Then I think we can move to the next question. If anybody has any doubt in any of the previous questions, please write it in the chat box or unmute your mic and ask. I'll move to the next question. Next question is rate law for a reaction involving the reactants X, Y, and Z is found as rate is equal to K into concentration of X to the power of 3 multiplied by concentration of Y raised to the power of 2 by 3 multiplied by concentration of Z raised to the power of 1. How would the rate of the reaction change when the concentration of X is reduced to X by 2 and concentration of Z is octupled, that is 8 times increase. So the concentration of X is becoming half and the concentration of Z is now becoming 8 into Z. Okay. So what would be the change in the rate? Your options are option A increases by 1 by 4. Option B remains the same. Option C increases by 2. And option D reduces by 1 by 8. Write your answers in the chat box. Okay. And I'm seeing option B in the chat box. I request all of you to try to solve and write your answers in the chat box. I see only 5 or 6 people who are answering in every class. So please, this will help you solve the questions quickly. Okay, so I see majority answers as option B. Let's see, remains the same. That is the correct answer. The rate remains the same. Let's see how do we solve this. So the rate of the rate of the reaction is already given as an equation. Okay, let's see. That is the first equation: k into x cube, y raised to the power of 2 by 3, and z. Now the new x is becoming x by 2, new z is becoming 8z. So the second reaction, second rate equation would be k into x by 2 whole cube into y. Nothing is happening to y, so y will remain same, and instead of z now it is 8z. So now if you see 2 raised to the power of 3 is 8, 2 cube is 8. So you have extra 8 in the numerator and the denominator, so that will get cancelled out, and the second rate will be equal to the first rate equation, that is kx cube y raised to the power of 2 by 3 and z. So that means there's no change in the overall rate of the equation because because of the change in the concentration of x and z individually. Okay, is this clear to everybody how to solve this and how do we get this answer?
Yes, ma'am.
Okay, great. If anyone has any doubt, please write it in the chat box. So the answer is option B remains the same. Okay. Moving on to the next question, question number 5. When Cl2O7 decomposes at 550 Kelvin in the gas phase to form chlorine and oxygen gas, it follows a first order kinetics. After 2 minutes at 550 Kelvin, the pressure of Cl2O7 falls from 0.1 to 0.05 atmosphere. What is the approximate rate constant? So you have to calculate the rate constant. The rate reaction order is given as first order kinetics. So use the first order rate equation. The initial and the final pressure is given. The time is given. So you have to sorry, you have to calculate the rate constant. Your options are 5.78 into 10 raised to the power of minus 2 per second. Option B 5.78 into 10 raised to the power of minus 3 per second. Option C 4.78 into 10 raised to the power of minus 3 per second. And option D 3.87 into 10 raised to the power of minus 2 per second. Okay. So the first order reaction kinetics, we have the time, we have the initial and final pressure, we have to calculate for the rate constant. Just use the formula that we have seen in the first slide and solve for the question. Write the answers in the chat box. I have only one answer in the chat box. What about others? Okay, I see 5 people have answered option B. Let's see if option B is the correct answer or not. That is the correct answer. So I told you, you just have to replace the values in the first order reaction rate equation. So you have the initial pressure, you have the final pressure, you have the value of T given. So you have to solve for K. Just replace the values, solve the equation, and you will get the answer. Just keep in mind that the time is given as 2 minutes. Your options are in seconds, so you have to convert the time into seconds. So 2 minutes would be 120 seconds. Rest everything will be same. When you will calculate the whole thing, you will get the answer. Anyone has any doubt in this, or anyone is having difficulty in calculation, please let me know, then I can help you out. I can tell you how to do these calculations. You can use your calculators for doing these calculations because you will have a digital uh, calculator during exams as well on your screen. So you can use a calculator, that is not a problem, but you should know how to use the calculator for solving these logarithmic equations or exponential equations. Okay. So is anyone having any difficulty in this question? Write it in the chat box. What, especially people who haven't answered in the chat box, I want people who have answered, I can understand that they have understood the question, they have got the right answer. But those who aren't answering in, at all, they should ask question if they have any doubt. Is this clear to everyone? Okay. Okay, then let's move to the next question. Question number 6. For the reaction 2A plus B goes to C, for this reaction, find the rate law from the following data. So you have to find the rate equation. So you have 3 sets of data where concentration of A, concentration of B, and rate is given. Okay, in 3 different scenarios, 3 different rates are given and 3 different concentration of A and B are given. Okay. Based on this, you have to deduce the rate equation. So options are: option A, rate is equal to K concentration of A raised to the power of 2 multiplied by concentration of B. Second is rate is equal to K into concentration of A multiplied by concentration of B raised to the power of 2. Third equation is rate is equal to K into concentration of A into concentration of B. And option D is rate is equal to K into concentration of A raised to the power of half multiplied by concentration of B. Write your answers in the chat box. I already see 2 people have answered. I'll wait till rest of you answer and then we'll have the discussion. So this will be based on the previous knowledge that we have learned, that rate is equal to rate constant multiplied by the reactant concentrations raised to the power of the individual order. So this will be K in rate is equal to K into concentration of A raised to the power of n multiplied by concentration of B raised to the power of m. Okay, so like that you have to frame 3 equations. You have 3 rates, 3 concentrations. So you frame 3 equations and then from that you will deduce the power values of the individual power. So I see most of you have written option A as the correct answer. Let's see if it is the correct answer or not. It is the correct answer, option A. Let's see how to solve this. So I told you the rate is defined as K into concentration of A raised to the power of m multiplied by concentration of B raised to the power of n. So basically what you have to do is find m and n, the values of m and n. So you have 3 different rates, right? 0.25, 0.5 and 4.5. For 0.25, the concentration of A is 0.3 and concentration of B is 0.03. So the equation will become 0.25 into K multiplied by 0.3 raised to the power of m multiplied by 0.03 raised to the power of n. So this will be your first equation. Similarly, the second equation would be 0.5 into K. Now concentration of A is again given as 0.3. So 0.3 raised to the power of m. The concentration of B is given as 0.06. That will be raised to the power of n. That will be second equation. Similarly, you write the third equation, that where rate is given as 4.5, concentration of A is given as 0.9 and concentration of B is given as 0.06. Now if you see in the first and second equation, value of A is common. In the second and third equation, the value of B is common. So if you divide the third and second equation, you can actually eliminate the term where n is there and you can solve for m. So our value of m is coming to be 2. And again, if you do the same thing with second and first equation, you will get the value of n as 1. Look at the people who haven't understood or people who haven't answered. Look at the calculation here and see if you are also getting m is equal to 2 and n is equal to 1. So once you have the value of m and n, you can just replace. So this will be rate is equal to K into A raised to the power of 2 and B raised to the power of 1. So that will be equal to this option A. Is this clear? People who are not answering anything in the chat box, please let me know if this is clear to you. It's okay if you don't want to answer, I can't force you, but then I request all of you to try to understand this so that it will help you in your exams as well. Not just the NPTEL exams, these questions will help you solve the competitive exams in future as well. Okay. I hope this is clear to everybody. Let me know if you have any doubt. Write your doubt in the chat box so that we can have a discussion. Till then, I'll move on to the next question. That is question number 7. Consider the following reaction. 2O3 goes to 3O2. So ozone is going to oxygen. Rate of appearance of O2 is 4.25 liter per second over the first 6 seconds. Okay, over the first 6 seconds, the rate of appearance of O2 is 4.25 liter per second. How much oxygen will be formed during this time? So rate is given, time is given. You have to find the concentration of oxygen that will form during this first 6 seconds. How many liters of oxygen will form during this first 6 seconds? Your options are option A 22.4 liter, option B 255 liter, option C 25.5 liter, option D 32.5 liter. Everybody do your calculation and let me know their answer in the chat box. Okay, so I see most of you are answering option C as the correct answer. So that is 25.5 liters. Let's see if that is the correct answer or not. That is the correct answer. So this is again very simple question. The rate I've told you, rate is defined as minus dA by dt or dC by dt. If you are talking about product concentration, it would be in positive. If you are talking about the reactant concentration, it would be in negative. Change in the reactant concentration will go in negative. A change in the product concentration will go in positive. So here we have to solve for how much oxygen will be formed, that is the product concentration. So we will take the positive value. So rate will be equal to dC by dt. So rate is given as 4.25. Time dt, the change in time is, say first, so they have mentioned first 6 seconds, so it is basically 0 to 6 seconds. So 6 minus 0 would be 6, so dt would be 6. So change in concentration, so initially there will be no oxygen, so how much oxygen in liters would be formed? So that would be your dc. So you have to just simply calculate for dc. So 4.25 is equal to dc by 6. So 4.25 multiplied by 6 is equal to dc. So that comes to 25.5 liters. So the concentration of oxygen formed in the first 6 seconds would be 25.5 liters. Okay. I hope this is clear to everybody.
Yes, ma'am.
Okay, great. Let me know
Yes,
if
ma'am.
anybody has any doubt. Otherwise, I'll move to the next question. Okay. Moving to the next question, question number 8. In a study with groundwater sample, it was observed that tetrachloroethylene, that is TCE, is degraded following the first order kinetics with the half life of 144 hours. So it is following first order reaction kinetics. Half life is given as 144 hours. If the current groundwater concentration of TCE is 14 microgram per liter, how long approximately will it take before the TCE concentration is reduced to drinking water standard, that is 2.5 microgram per liter? So you have the half life given, you have the current concentration given 14 microgram per liter, and the final concentration that you wish to achieve, that is 2.5 microgram per liter. So you have initial concentration, final concentration, half life, and the order of the reaction is given, so you know which equation has to be followed. So use that equation, first order reaction kinetics. So use the first order reaction kinetics and solve for the time it will take for 14 microgram per liter TCE to reduce to 2.5 microgram per liter. Options are option A 375 hours, option B 458 hours, option C 289 hours, and option D 358 hours. So you have the half life and the first, and it is mentioned that it is a first order kinetic. So first thing you do is calculate for the rate constant. Once you have the rate constant, you can again calculate for the time by using the initial and the final concentration given. Okay, that was the hint. Use the values and solve. Let me know the answer in the chat box. Okay, I can already see one answer in the chat box. All of you solve quickly and then we'll have the discussion. I'll give you time to solve and write. Okay, three answers are here. All of them are option D. What about others? Okay, so I see most of the answers are option D, 358 hours. Let's see if that is the correct answer or not. That is the correct answer. So basically, half life is given. I told you first you calculate the rate constant. So log of C0 by C is equal to KT. This is the first order reaction rate equation. So you have half life given. That means C0 by C is equal to 2. This we have seen in the second question that was about the radioactive decay. So ln2 would be equal to 0.693 divided by the half life, that is 144 hours. So you get the rate constant. Now from this rate constant you have the initial concentration of 14 microgram per liter, final concentration is 2.5 microgram per liter. Rate constant you have already calculated, so you can calculate the T. So you will get the value of T to be 358 hours approximately. Okay. Anybody has any problem in the calculation or in this question, understanding the question or understanding the solution? Please let me know in the chat box. Okay. If there's no doubt, then I'll move to the next question. Then question number 9. Half-life of 2,4-D, that where the degradation follows first order kinetics, is estimated to be 14 days. How long would a waste containing 20 mg per liter of 2,4-D have to be stored in order to reduce to 0.5 mg per liter? So half life is given as 14 days. So how long will it take to reduce from 20 mg per liter to 0.5 mg per liter? It is very similar to the previous question, so everybody should be able to quickly solve this. Half life is given, so you can calculate the, and the reaction order is given as first order kinetics. So you calculate the rate constant and then calculate the time it will take to reduce from 20 mg per liter to 0.5 mg per liter. You have the initial and the final concentration. Quickly, everybody solve this. It's very similar to the previous question, so you should be able to solve it very quickly. I already see Tanishka has solved the question. Let's see what about others. Let's see if her answer is also correct or not. Everybody quickly solve this. Okay, I see many of you have answered option B. Let's see if that is the correct answer or not. 74.5 days. So that is the correct answer. 74.5 days. It takes 74.5 days for it to reduce from 20 mg per liter to 0.5 mg per liter. So the solution is similar to the previous one. You calculate the half life. So for calculating half life, you simply divide it by, sorry, you calculate the rate constant from the half life. So half life is given as 14 days. So you simply divide 0.693 by 14, so you will get the rate constant. Once you get the rate constant, you have the initial concentration 20 mg per ml, 20 mg per liter, final concentration is 0.5 mg per liter. So 20 divided by 0.5 would be 40, and then natural log of 40, take solve for natural log of 40 and divided by 0.495, you will get the answer to be approximately 74.5 days. Is this clear to everybody? Anyone having any doubt in this question or the calculation, please let me know. I can help you explain it. I'm explaining it quickly because most of you, I can see, are giving the correct answer. So I'm hoping that everybody understands this. People who haven't answered, I request them to ask question. If you won't ask question, I will not be able to know whether you are actually understanding it or not. So unless you ask question, I will not be able to help you out with any of the questions because I will not know if you are understanding or not. So please
Can you
ask.
do the previous slide once?
Previous slide, so like the previous solution.
No, ma'am, this question.
Okay, question, you just want to see the question. Okay, this is the question.
Thank you, ma'am.
Yeah, okay. Anybody else wants to ask anything? Okay. Okay, then let's move to the next question. Question number 10. It is found that the disappearance of chemical compound follows first order kinetics, and after 20 seconds the concentration was 60 mg per liter. Let the initial concentration be 150 mg per liter. Find its approximate rate constant value. So you have the order of the reaction given, for it's again first order kinetics, so you know what formula to be used. Time is given 20 seconds. Initial concentration is given 150 mg per liter. Final concentration is given 60 mg per liter. You have to solve for rate constant, that is value of K. So simply put all the values in the equation, solve for K. Options are 4.58 per second, option B 0.65 per second, option C 0.046 per second, and option D 1.5 per second. So all of you solve and write your answers in the chat box. Okay, I can see 4 people have answered option C. What about others? I'll wait till others also solve and then I'll discuss. Okay, I see many of you have answered option C. That is the correct answer, 0.046 per second. So we have discussed many first order reaction rate equations. So I hope by now you understand. So initial concentration is 150, final concentration is 60, time is 20. So just replace the values, solve. 150 by 60 would be 2.5, and natural log of 2.5, take that and then divide it by 20. The answer would be approximately 0.046. Okay. So this is a very straightforward question. I hope this is clear to everybody. Anybody, if you have any doubt, please ask in the chat box or unmute and ask. I'm fine with both. Okay. If there's no question, then I can move to the next question. Right? The next question, again, a first order reaction, is 12.5% complete in 45 hours. To have 75% complete, it will take approximately, so you have two equations basically. In first case, in 45 hours, the reaction is completed by 12.5%. So what would be the time for the same reaction to complete 75%? So use the first order rate equation for the first situation, and then from that the rate constant can be used to solve for the second equation to calculate the time. First you calculate the rate constant. It is similar to the half-life question, just instead of the half-life you have 45 hours and 12.5% completion. So you have the initial and the final concentration given in a different manner. So try to understand the question, try to solve the question, write your answers in the chat box, and then we'll have the discussion what would be the correct answer. All of you quickly solve it. Okay. Okay, I see. A lot of you have answered option D. That is 19.45 days. That is the correct answer. So, this is the first order reaction kinetics. The first statement says it for 12.5% completion, it is taking 45 hours. So, simple way of solving such percentage based question is to assume that the initial concentration is 100. Okay. So, if the initial concentration is 100, the final concentration would be 100 minus 12.5, because 12.5% of that reactant concentration is used up or consumed or reduced. So initial concentration is 100, then final concentration would be 100 minus 12.5, that is 87.5, and time is 45 hours. So just take 100 divided by 87.5, take the natural log and divided by 45, you will get the rate constant. Now once you have the rate constant, the next is uh, completion of 75% reaction. So that means the final concentration would be 100 minus 75, that is 25. So then from that you can calculate the time. Now this time will be in hours because the initial time was in hours. So the rate constant that you calculate was in hours. So the time that you will get will be in hours. The options are given in days. So you have to divide the number of hours by 24 to get the number of days, and the number of days comes to approximately 19.45. So this is just majorly you have to do the calculation correctly. You have to make sure that while making the entry in your calculator you don't make a mistake, because questions are fairly straightforward. Questions are equation based. So if you know the equation, if you understand what first order reaction is, what is the rate equation for the first order reaction, you will be able to solve all these questions. But the trick is to do the calculation carefully, because there's a lot of decimal places here and there, and there can be a lot of calculation mistake that can happen in such questions. So you have to be little careful with that. Okay, I hope this is clear to everybody. This is fairly straightforward. If you still have any doubt, please ask in the chat box or unmute and ask. I'll be happy to help. Okay. Okay, if there's no question, then let's move to the next question. Question number 12. Eh, Till now, if you have any doubt in any of the question, please write it in the chat box. I'll look into it. Question number 12. Consider the reaction B goes to C. It is found that the rate of the reaction increases by factor of 4 when the concentration C is quadrupled. That is, C is also become increased by 4, or C is becoming 4 times of C. The reaction is, so order of the reaction is basically option A 0, option B first, option C second, and option D third. So you have the reaction B goes to C. If reaction rate is increased by 4, the concentration is basically, if the concentration of C is quadrupled, that is increased by 4 times, the reaction rate is also increasing by 4. So what is the order of the reaction? Okay, I see many of you are answering option B. Anyone else wants to write the answer? I'll wait. Okay, option B, that means first order. The rate of this reaction is first order. That is the correct answer. You all are right. So, how to solve this? This is similar to what we had solved previously. So, the rate of the reaction is given as K into concentration raised to the power of the order. Okay, so in this case, this will be Kc to the power of n. So, this would be the first equation. The second rate equation would be R2, where R2 is 4R1 is equal to K into 4C raised to the power of n, because C is also quadrupled. So now if you divide second equation by first equation, R1 will get cancelled by R1. So 4 will be equal to 4 raised to the power of n. So that means n is equal to 1. So that order of the reaction is equal to 1, or it is a first order reaction. Clear, everybody? So I hope this is a simple question.
Yes, ma'am.
If anyone has any doubt, please write it in the chat box. I'll move to the next question. Till then, question number 13. The reaction has been found to have an activation energy of 25,000 calories per mole. Anybody has any question? Titli, could you unmute? Could you mute your mic, please?
তাহলে বইলেই যুব সাথীটা ফিল আপ করো। বাস ওইটা 21 বছর।
I request everyone to please keep your mics muted.
আরে আমার হবে নি 21 বছর থেকে। বয়স কত হয়েছে? 20 দিয়ে দেখ। হ্যাঁ, হয় না। 59 বছরে করছে, দেয় নাই লক্ষ্মী ভান্ডার, অতই সোজা। 20 এখনো হয় নাই, জুনে হবে। ও পাইবে নাকি? যুব সাথী মানে যুবক? না, এটা সবাইরই দেবে।
Okay. The reaction has been found to have an activation energy of 25,000 calories per mole, a specific reaction rate constant of 5 per second at 27 degrees Celsius. Calculate the specific reaction rate constant approximately at 0 degrees Celsius, given R is equal to 1.98 calories per degree per mole. So the value of R, that is the gas constant, it is given. The activation energy EA is given as 25,000 calories per mole. The specific rate constant is given at 27 degrees Celsius. You have to calculate the rate constant at 0 degrees Celsius. Okay. So if you know how to solve this question, please solve and write your answers in the chat box. Options are option A 0.08 per second, option B 0.16 per second, option C 0.04 per second, and option D 0.12 per second. Everybody write your answers in the chat box. I see 2 answers in the chat box right now. All of you answer and then we'll have the discussion. Only 4 people have answered option A. What about others? Okay, I'll tell you how to solve this question. Option A, that is 0.08%, that is the correct answer. So these questions could be solved directly from the equation log K2 divided by K1, which is the specific rate constant at temperature T2 divided by the specific rate constant at temperature T1. So the rate of the reaction is dependent on temperature, just like equilibrium is dependent on temperature. The rate of the reaction is also dependent on temperature. So at different temperature, the rate constants will be different. So K2 is the rate constant at temperature T2. K1 is the rate constant at temperature T1. Now, the equation goes like log of K2 divided by K1 is equal to EA by R. EA is the activation energy, R is the gas constant, multiplied by 1 by T1 minus 1 by T2, where T1 and T2 are the initial and the final temperature. Now, these temperatures, the main thing that you have to keep in mind in these kind of equations are the temperature is given in Kelvin. Okay. So, in the question, you can see the temperatures are given in degree Celsius. So, first you have to convert the degree Celsius to Kelvin. So, for that, just add 273 to it. So, 0 degree Celsius will become 273 Kelvin, 27 degrees Celsius will become 300 Kelvin, that is 273 plus 27. So T1 becomes 300, T2 becomes 273, K2 we have to calculate, K1 is already given as 5, EA is given as 25,000 and R is given as 1.98. You just have to replace the values to this equation and solve for K2. Anybody has any doubt in this? I see few people have answered for this question. So people who haven't answered, please look into the solution and let me know if you still don't understand this. I'll explain it.
Ma'am, in this particular question, ma'am, like the temperature which you have taken for Kelvin, like here the temperature given here is 27 degrees Celsius, and I have added like 273.15 degree Kelvin, which is the real Kelvin value for 0 degrees Celsius. So, ma'am, when I added that, so ma'am, the value for both of them is like 300.15 and 273.15. So my value was little bit higher than that of the like the original value which you got in this answer. So, ma'am, I just
What
did the
is the
approximation while pointing the value.
generally when we calculate for such questions to keep it more simplified, we take 273 Kelvin as 0 degree Celsius. So uh, it would be easier for you also to do the calculation if you take the approximate value rather than the exact value. Even if you take the exact value, what is the answer you are getting?
Ma'am, it's near to like 0.00796, like
Yeah,
this.
so if you look at the options, it is already rounded up to two decimal places. So 0.078 or 0.079, both of them will give you the answer of 0.08. If you look at the
So,
options, it
ma'am,
is, yeah.
yes, ma'am. As it is a MCQ question, so I am getting like the options nearby.
Hmm.
But if it is a like a theoretical question answer, like if I have to solve it in the paper,
Still,
then at that time,
still like
will there be an
in
issue?
yeah, no, no, no. So in the like in the exam or in any of the other competitive exams also, like gate and everything, if you have a question where you have to type the answers are always given in the range of a decimal place. So if the answer is 0.079 or 0.78, the correct answer in the answer sheet will always be given as 0.078 to 0.08. So whatever answer you write between this range would be the correct answer. Okay, so it generally, or it's already given in the question that write the answer to the up rounded off value up to 2 decimal places or something like that. So if it is asked in a non MCQ format, you will be given in the question that how you have to answer. Okay, so that there won't be any problem with that.
Okay, ma'am.
Okay,
Thank you, ma'am.
yeah, welcome. Anyone else has any question or any doubt in this? So for your ease, I would request all of you to take 0 degrees Celsius as 273 Kelvin. So it would be easier for you to do the calculation, because these calculations already go up to many decimal places and like it takes time. So because in a competitive exam, along with the precision, it also is important for you to solve the questions as quickly as possible, so that you can solve many questions in that 1 hour or 2 hour time slot. Okay, so in that case, for simplicity, I would request all of you to take the rounded off values for doing the calculation. Especially for MCQ format or for competitive exams, it is very important to solve the answers quickly than to get the very exact answer. Okay, so anyone else has any doubt, let me know in the chat box. Otherwise, I'll move to the next question. Question number 14. The aerobic decomposition of hydroxylamine, that is NH2OH, follows the rate expression as rate is equal to K into NH2OH concentration multiplied by O2 concentration. Let K is 0.096 into 10 raised to the power of minus 3 liter per mole per second at 27 degrees Celsius, and 1.04 into 10 raised to the power of minus 3 liter per mole per second at 50 degrees Celsius. Calculate EA. The approximate value of EA is. So you have to calculate the approximate value of EA, that is the activation energy. You have been given the K1, K2, T1, T2. The value of R you have to take in kilojoule format, because the answer is given in kilojoule per mole. So you have to take the value of R in joule or kilojoule format. So you should know the R value of R in different units, because it's the gas constant. Sometimes they give the value of R in the question, like they have given it in the previous question, but sometimes the value of R is not given in the question. So you should also know, all of us have studied what is R, what is the gas constant in school time. So I hope basic knowledge about that should be there with everybody. So calculate and let me know the activation energy, what you are getting. For now, I'll tell you the value of R. Value of R is 8.314 joules per mole per Kelvin. So take the value of R to be 8.314 and calculate. You will get the answer in joule. Just convert it into kilojoule. Just divide it by 1000 and then give me the answer. So you have now K1, T1, K2, T2, and R I am telling you is 8.314. Okay, quickly calculate. Yeah, I have only one answer in the chat box. What about others? Do your calculation quickly. You have all the values. You saw the equation in the previous question. You just have to replace the values in that equation and solve. So the equation is log K2 upon K1 is equal to EA by R multiplied by 1 by T1 minus 1 by T2. So you have K2 1.04 into 10 raised power of minus 3. K1 is 0.096 into 10 raised power of minus 3. T1 is 27 degrees Celsius, so that would be 273 plus 27, that is 300. T2 would be 50 degrees Celsius, that is 273 plus 50, that would be 323, I guess. Okay, I see 4 people have answered. 83.4 kilojoule per mole. Option C. Let's see. So you have to calculate the approximate value, so it can come like the decimal place can be a little bit here and there. It's okay, but only 4 people are able to solve. What about others? There were so many people answering initially. What happened to all of them? Only 4 people are now actively solving. Rest of them, what are you doing? You don't want to solve anymore? Okay, let's see the solution. So I told you it's the simple equation. Just replace the values K1, K2, T1, T2 and solve for it. I told you take the value of R as 8.314 and you will get the answer as 83,000 something something. So just divide it by 1000, you will get the answer as 83.4 kilojoule per mole. Okay, all of you are getting this answer. People who haven't answered, please let me know if you are getting this answer or not. Is this clear to everybody?
Yes, ma'am, clear.
Okay, great. Then I'll move to the next question. Question number 15. If the first order rate constant for bacterial decay is 0.20 per day at 20 degrees Celsius, and if an A for equation K2 is equal to K1 A raised to the power of T2 minus T1 for 1.035 is assumed to describe the effect of temperature on the rate constant. Okay, so the value of A is given in this equation, this particular equation, K2 is equal to K1 A raised to the power of T2 minus T1. What are the first order decomposition rate constant at 30 degrees Celsius and the value of EA, approximate value of activation energy, and the first order decomposition rate constant? So first you have to calculate for, so K1 is given, the first order rate constant 0.2 is given at 20 degrees Celsius. So K1 is given, T1 is given. So at 30 degrees Celsius, that is T2, what would be the K2? First calculate that from the given equation and then calculate the activation energy from the equation that we used in the previous question. Quickly solve this question and write your answers in the chat box. Okay, we already have one answer, option C. Okay, that was okay. Let's see what about others. Come on, everyone, solve quickly. One person has already solved the question, so you all should be able to solve it as quickly as possible. Okay, there are 2 answers, option C. What about others? Okay, I see many answers as option C. Let's see. So the equation is given in the question. K2 is equal to K1 a raised to the power of T2 minus T1. So T2 is 30 degrees Celsius. That is 30 plus 273 would be 303, and T1 is 20. T1 is 20 degrees Celsius. So 273 plus 20, that is 293. So T2 minus T1 would be 303 minus 293. A is given as 1.035 in the question. K1 is given as 0.2, so you can solve for K2. K2 is coming as 0.282 per day. Now, from this, now you have the K2, that is 0.282, K1, that is 0.2. R, since the question is given in the question, the rate constants are given in per day. Okay, in the option it is given in joules, so you have to take the value of R as 8.314. Activation energy EA that we have to calculate, T1 is 293, T2 is 303. Just solve for the whole equation, you will get the option, you will get the answer of activation energy as 25.36 kilojoule per mole. If anyone has any doubt in this, please let me know. Everybody is getting this answer. I see a lot of people have answered option C. Others also, I hope they are getting, you are understanding how to solve this question and you are getting this answer. Let me know if there's any doubt. Okay, write your doubt in the chat box. I'll move to the next question, question number 16. A sample is known to have a maximum absorbance at a wavelength of 356 nanometer. Its molar absorptivity is 7200 liter per mole per centimeter. Width of the cuvette is 1 centimeter. Spectrophotometer finds absorbance A as 0.6. What is the concentration of the sample? So the absorbance is given, the width of the cuvette is given, the molar absorptivity is given. You have to calculate the concentration of the sample, approximate concentration of the sample. So the equation that you have to use is the Beer-Lambert's law equation. So if you know the equation, write your solve it and write your answers in the chat box. I'll wait for people to answer and then I'll discuss. I'll tell you what the Beer-Lambert law is. Okay, I already have one answer in the chat box. Option B. What about others? Quickly solve this. Okay. 3 people have answered option B. Option B is the correct answer, 8.33 into 10 raised power of minus 5. So Beer-Lambert law basically states that the absorbance of any sample is directly proportional to the length of the path length of the light, that is the width of the cuvette. So width of the cuvette will be equal to the path length because the sample is inside the cuvette and the light is passing through the cuvette from one end to the other. So the width of the cuvette would define the path length. So the absorbance is directly proportional to the path length and concentration. So higher the concentration, higher will be the absorbance, or smaller the path length, lower will be the absorbance, or larger the path length, higher will be the absorbance. So that is the Beer-Lambert's law. And molar absorptivity is just the proportionality constant. So A is proportional to L and A is proportional to C. When we write it in the equation, we have to insert a proportionality constant to make it equal, so A is equal to epsilon, that is the molar absorptivity constant, multiplied by L, that is the path length, multiplied by C. So in this question, you have the epsilon value given as 7200, path length is given as 1, and the concentration you have to solve, absorbance is given as 0.6. So concentration can be solved, 0.6 divided by 7200 into 1. So 7200 into 1 would be 7200. So 0.6 divided by 7200, you will get the answer as 8.33 into 10 raised to the power of minus 5 moles per liter. That is the concentration of the sample. Okay. Is this clear to everybody? Anybody has any doubt, please write it in the chat box. No doubt.
Ma'am,
Yeah.
what was that relation according to the Beer-Lambert's law, which you said that according to the path length of the light?
So it is directly, absorbance is directly proportional to the concentration as well as the path length. So just a second. Just a second. Let's see if I can explain you. So if we have a cuvette, okay, and we have the sample in this cuvette, okay. So what we'll do, we'll put this inside a spectrophotometer. So what happens in a spectrophotometer, there is a light source and the light passes through the sample and comes out from the other direction, and here we have the detector. We have the detector that detects and notes the absorbance value. Okay, so now this absorbance is basically how much light is absorbed by this sample. Okay, so how much light is being absorbed, based on that. So if, let's say, 100%, from 100%, 25% is absorbed, so 75% will be detected by the detector. 75% of the light will be detected by the detector, and the detector will give the information that the transmittance is 75%, that means absorbance is 25%. So based on that, you will get some absorbance value. Okay, now that absorbance is directly proportional to the concentration. So A is directly proportional. A is directly proportional to the concentration, and A is directly proportional to the path length. Path length means the path of the light that it is traveling through the sample. So from this point to this point, the length of the light that is traveling through the sample. Okay, so this will be the path length. So this is basically equal to the width of the cuvette, right? So width of the cuvette is given here as 1 centimeter. So the value of L is 1 centimeter. And when A is proportional to C and A is proportional to L, when we write it in the equation format, we generally write a proportionality constant, and so A is proportional to C, A is proportional to L, and the constant that here we are introducing is the molar absorptivity constant. Okay, that is a constant value for every sample. Is that clear?
Yes, ma'am.
Okay. So the next question is, what are the functional groups present in 4-aminophenol? Sorry. What are the functional groups present in 4-aminophenol? Option A, 1 nitro group and 1 amino group. Option B, 1 amino group present in the phenyl ring. Option C, 1 amino group and 1 phenolic OH group. And option D, 2 amino groups in the phenyl ring. What would be the correct answer? What are the functional groups present in the 4-aminophenol? It's a theoretical question. You should not take much time to answer this. All of you write your answers in the chat box. What are the functional groups present in 4-aminophenol? Come on, write your answers in the chat box. There's nothing to calculate in this. Could you please show us the previous slide? I'll show you the previous slide. Here's the previous slide. Mobani, can you see the previous slide? Mobani?
Yes, ma'am.
Yeah.
Yes, ma'am. Yes, ma'am. Thank you, ma'am.
Yeah, okay. So, okay, I see most of you have answered options C, one amino group and one phenolic OH group. That is the correct answer. It's a straightforward question. So, this is how 4-amino phenol will look. So, you will have one amino group, and at the fourth position, so you will have one phenolic group, and at the fourth position, you will have amino group. So, that's why. So, since O has a higher priority, this is the first carbon. So 1, 2, 3, and 4. Fourth position, you have the amino group. That's why it is named as 4-amino phenol. So when you add OH to the benzene ring, it becomes phenol. And when you add one amino group at the fourth position, we name it as 4-amino phenol. Okay. I hope there's no doubt in this question. If still there's a doubt, let me know. Moving to the next question. What is the unit of the rate constant of a second order reaction? We have discussed this in the initial part of the question. Still, I request all of you to solve for the unit of the rate constant for second order reaction. Options are option A, liter per second, option B, mole per second, option C, per liter mole per second, option D, liter per mole per second. I see option D to be written by 2 people. Okay. Okay, now most of you are answering option D. Option D, liter per mole per second. That is the correct answer. So I told you how to solve for the unit for the rate constant. So this is dC by dt. So concentration would be moles per liter, and time would be second. So moles per liter per second divided by, so this is C square because it's a second order reaction. So divided by moles per liter whole square. Just solve for this. So mole per liter will get cancelled by one of the mole per liter. So this will be liter inverse will become liter, mole will become mole inverse, and per second will remain as per second. So liter per mole per second. I hope this is also clear to everybody. Next question is 2,4-D in aqueous solution shows its lambda max in the UV range. We want to measure the absorbance at its lambda max. We must use a cell or a cuvette made of option A glass, option B plastic, option C quartz, or option D any one of the above is okay. So the lambda max, that is the maximum absorbance wavelength at which maximum absorbance of this particular compound is measured in aqueous solution, it is in the UV range. So if the maximum absorbance is in the UV range, which cuvette should we use? Should we use a glass cuvette, plastic cuvette, or quartz cuvette? And whatever answer you are giving, I want somebody to give an explanation also if possible. If I see 2 people are written quartz cuvette, can you answer why do we need to use quartz cuvette? Tanishka or R.I. Malia? Anybody?
Now, ma'am, may I?
Yeah, sure.
Mostly the quartz is being used in the watches as well. So we can say that the quartz, it is being actually made up of a fusion of silica material, and it is actually transparent in the UV range. So it is also said to be as a standard material for the spectrophotometric conditions, like for the test which is being done, and it is used for like UVV rays spectroscopy, and it's like its range for the wavelength range is mostly like below 340 nanometers, so that's why.
Yes. So basically, quartz do not absorb in the UV range, whereas glass and plastic can absorb. So the absorbance, basically, you are using the cuvette to measure the absorbance of your sample. So if your cuvette material itself has some absorbance in that particular range, the absorbance value that you will get in the spectrophotometer will not be accurate. So to get the most accurate absorbance value, you have to use a material that does not absorb in that particular range at all. We can use a glass or plastic cuvette if we are measuring the absorbance in the visible range. Like if we are measuring the absorbance as at 600 nanometer, let's say, we can easily use a glass or plastic cuvette, because at that particular wavelength, glass and plastic also does not absorb the light at that particular wavelength light. But quartz will not absorb the will not absorb the light at the wavelength of UV range, whereas glass and plastic cuvettes can. So that's why quartz is used to measure the absorbance of a sample in the UV range. Okay, so this was the last question of the session. Please let me know if you have any doubt in any of the questions. I'll be happy to help you out. Any doubt? Yeah, sure, Samadita. You're raising your hand. Yeah.
In the assignment, ma'am, there was one question that is in a second order reaction, the concentration of the reactant after 10 minutes and 20 minutes of reaction is 15 mg per liter and 10 mg per liter. Find out the initial concentration of the reactant.
Hmm.
Like, ma'am, can you show us by solving this particular
Yeah.
question?
So, can you tell? I'll just solve it here and see if my thoughts are. Yeah. Can you tell me the values? It's a second order
Um,
reaction, right?
yes, ma'am. Yes,
Okay.
ma'am.
I'll just go
And the
through the
values
first
are
one.
like, okay,
Yeah.
ma'am.
Just a second. So here you will be able to understand easily. Yeah. So first order reaction, the values are uh,
Ma'am, it is like a second order reaction,
sorry,
and
second order reaction, and the values are time
ma'am,
is
the time is for 10 minutes. The concentration of the reactant is 15 mg per liter,
okay, and for next time is
and
20 minutes.
for 20 minutes it is like 10 mg per liter.
Okay. So for this question, what you can do is you can assume the initial concentration to be X, let's say. So the final concentration in one case is 1 by 10 will be equal to K into 20, because time is 20, plus 1 by X. So this will be one equation. The second equation will become 1 by 20, wait, uh, 10 mg per ml, it is 20 minutes, and 15 mg per ml, right? So 1 by 15 is equal to K into 10 minutes plus 1 by X. So these will be two equations. So you can either write it as 1 by X is equal to 1 by 10 minus 20K, and 1 by X is equal to 1 by 15 minus 10K. So if you so these are two equations. So you have two equations and two unknowns. So you can easily solve it.
Okay,
Are
ma'am.
you having any difficulty solving the equation? So then, or
No, ma'am, no, ma'am.
okay, just
Okay,
two equations and two unknowns. So you will get the value of X and K both from these equations.
okay, ma'am.
Okay.
Yes, ma'am. Thank you, ma'am.
Yeah. Any other doubt? Any other question from your assignment or from the questions that I have discussed? Okay, if there's no doubt, then I think I can end this session today.
Yes, ma'am. Sure.
Okay. Anyone else? If you have any doubt, I'll wait for 2 more minutes. Write your doubt or unmute your mic and ask. If you don't have doubt, then you can end the session. You can leave the session. Anybody wants to ask any question, please write the question in the chat box, or you can unmute and ask any question regarding this whole third week's topic. No questions? Okay, then if there are no questions, then I think I can end this session. Thank you everyone for joining.
Thank you,
Thank
ma'am.
you, ma'am.
Yeah, thank you. I'll see you this Tuesday for the fourth week's discussion. Okay, you will all get the link.
Thank you,
I'll
ma'am.
upload the recording for this session. Thank you so much. Okay, bye bye.
Thank you, ma'am.